our console. Right upper quadrant, we have the so-called environment. So there are more tabs, but the only tab that is really important at this point for you is the so-called environment. The environment shows you what object you have loaded. And objects can be anything. Objects can be data frames, as here, DF1. So that's my acronym for a data frame. And I usually label all my data frames as DF. And t-test would be an hypothesis test that we will do later in class, which basically also can be packed in what is called an object. So R basically calls this an object, and it's nothing else but a placeholder where everything is popped into that you want to assign to this object. Yes. Yep. And we will fill it up. So this is just remnants from previous classes. Good. So right lower quadrant, and this is what we're going to see today. Right lower quadrant basically shows you plots. It has more tabs again, but the tab you're literally interested in at this point in time are the plots. And we will create a scatter plot today, as we did in Excel with, what was it, athletic performance on the y-axis as the dependent variable as a function of hours of deliberate practice on the x-axis. And we will do the same thing. Good. So let's start off. So you go in a line and you see everything that is hashtagged basically is commented out. So this turns green. Everything that turns green or is green is not active code. So you run this and nothing will happen, which is good because you can make notes and comments and you can help yourself explaining what the line actually means. That will in several instances be quite important then. So if you go into line 2 and you press that, so there are several ways how you can run a line of code. One, and the most simple and straightforward one, is you go here to the right upper corner of your left upper quadrant, and you can hit on run. That's one way to do this. Another way to do this is, and that's my preferred shortcut or combination, is Control and Enter or Return. Control and Return will run the line of code you're currently in. So if you are in line 2 and you didn't do anything and you press Control and for those on a Windows computer, it's the same thing, but it's Control and Return. It's the same thing essentially. So Control and Return will basically run that line of code. So line 2, you likely started off with an empty environment. So this didn't do anything. But if you look here, let's say we have something in the environment like here, and you run line 2. And this is what I wanted to explain here with line 2. RM is basically a command that will remove objects from the environment. So basically, line 2 is designed in a way that it queries a list, and that list is basically consistent with everything in the environment. So it will entirely wipe your environment clean. Regardless of what the objects are, it will always empty it out entirely. And then at the end of the day, you will have an empty environment. Yes?
When you go on line 2 and click Control Enter, it doesn't show like the data, it just shows like clear the environment.
Yes. And that's literally what you want to do. You can clean the output with Control and L. That's how you wipe the console empty. And if you click on Control and Enter on line 2, it shows you exactly that command. It basically just indicates it ran it. That's all it does. If you have something in your environment, like right now, I have something in the environment. So this is this object. The RM command will wipe this out. I will remove everything from the environment. Yes?
I go to a different line, my environment's done.
Yep. If you go on line 6, it will fill up. And that's what we're going to do next.
Should I run the code?
You can actually, yes, you can move forward, but I will explain what the code means and why it presents it.
I'm on line my environment done.
Yep, let's go step by step and then it will fill up. Okay. Well, you were first. Sorry, I forgot your name.
Oh, I wanted to know if we need anything in our environment.
Oh, not yet, not yet. Yes. Yeah, excuse me.
It's not running.
It's not running for you. The RM doesn't run?
No.
Okay, so if you go on line 2 and you press Control and Enter, this does not happen. Yes, that makes a difference. I posted, did you enter it exactly how you need to enter it? Was the % R? Oh, no. Yep. So I posted an announcement how to run this in Colab. Yeah, and that is how you will need to enter this. So this was exactly here. And you will need to do this a little bit different. But basically, you need the following command. You need %R and then copy over that line of code. Then it will wipe your environment empty. So you need to do this. Yeah, like this. If you look here, you have %R. So you will have a separate little chunks. They're called chunks. And you basically, you start this chunk with %R, and then it will recognize it as an R code. If problems, we need to discuss this after class. There was another question. Yes.
If I ran something and glance it and it ended up in my R, how do I delete it? If I highlight it and it
That you don't need to highlight anything. You need to go on the right upper left upper quadrant. So what's really the core piece here is really this. So just delete everything in the console, press backspace, and just go on left upper quadrant, select or go in the line that you want to run without selecting anything. Because the problem is also if you select something, it will override the line. So it's not running the entire line, it's only running what you selected. So that is fine, don't worry about it. It's a standalone code. If worse comes to worse, you can always run the entire code by just pressing Control A, selecting everything, or Command A, selecting everything and running the whole thing there. So it's a standalone code. I've designed it as such. Okay, let's go back. Line, any other questions? Besides the million questions that you likely have. So I know R is a little bit, it's a little intimidating at first, but don't be intimidated. Yes, please.
How did you get the rest of those lines? Even if you get, even if you run the lines, maybe minus and stuff.
Yeah, just go line by line by line. It's a very stepwise process. Go by every line first. So really go first in line 2 and run line 2. That will wipe everything empty. That what changes down there, that's something you only have to pay attention to when it's being read. Once it's read, then there's something wrong. But if you go on line 2, that's perfectly fine. That line should run without a problem. If you go on line 6 next, and you just go, you don't have line 6?
When I open mine, I just have like dots.
That's the wrong code then. Yeah. No, you need to download this from Canvas and get this code. It's on module 6 on Canvas, and you need to download this. Okay, if we go now on line 6, you're running line 6 with Command and Enter. That will create automatically a so-called data frame. So you see here the code, and this is essentially an equal sign in R. So it will pack everything after that equal sign, after this pipe or after this arrow, it will pack everything afterwards into that object and will create an object that is called DFM2, which you see essentially here. And this object is essentially nothing else but our Stroop dataset. And I went through lengths to put this together here. So you see the data that we have worked on in Excel, basically just entered here manually, which is not pretty as a code, but it's just easier to run it like that. And that's how it became a standalone code that you don't have to worry about. You don't have to load any other data files. And it was just easier like that. So if you go now on the right upper quadrant and you click here on this little table sign at the end of the file name, it basically will open this data frame, and it will show you the same code and the same data as we have in Excel for our Stroop data example. So you created, by running line 6, you created the data frame containing exactly the same data as you had in Excel. Good. Once we have that, we can do now the same exercises we did in Excel. So if you maximize now the left lower quadrant a bit and you run line 7, it will basically run a code that will open that data frame and will show you that data. So you can always look at your data by addressing the object. So you just type it in and it will open the object and will show it to you. You can also do this by explicitly addressing variables, which is in Excel, the columns in the data frame. So if you say DFM2 and the $sign basically indicates that you want something inside that data frame, it gives you congruent. It gives you only that column. So if you run line 8, it will only show you the congruent data entries. Yes, please.
Isn't that the same thing that was in the other tab? Like,
Exactly, yes. It's just displaying it directly in R. So R and RStudio are two different entities, right?
Right, but I'm saying if we have it on the top there, we don't need to put it down by R. If it's on my computer right now, in the other tab, do I have to bring it down into the R, or I can leave it in other tab?
I'm not sure what you mean with bringing it down. So if you run DFM2, that line of code,
On top
it's right here, right?
Yeah.
Okay.
R.
It is already in R. So this environment, is it R related? Or?
Yeah.
Okay. Okay. Yes, this is line 6. So whatever you have in the environment is what R has loaded. So you have that basically in the environment in R. This is only a graphical representation of what you have loaded in R. So this is nothing else. Yes.
Once for the data, when you clicked on it and it showed the chart, how did you now add it to the bottom?
You basically, if you go on lines 7, 8, and 9, these 3 lines are basically doing nothing else but displaying your object. It's showing it. So you have here, if you run the whole thing, it shows you the entire data frame. You highlight it and you run that. So whatever's highlighted will be processed by R if you press Control and Enter. If you only are with a blinking cursor in one line, it will run the entire line. That is the distinction. Yeah. Yes. That's we need to look at this after. Let's look at this after. Colab is a little chunky. Can we have one conversation, please? Thank you. Yes.
If I only want to run, let's say, the congruent or the incongruent, then I only run that line.
Exactly. So it's basically displaying whatever you say it should be displaying. Yes. Any other question? Do you have any questions? What's the question? Okay. You have a recording too, so that may be helping. We're gonna get your RStudio installed and then you can follow along. Yes. No? Yes? Yes?
So I'm like, you're highlighting things and things change in your console. Nothing's changing in my console.
Okay, did you run line 2? Okay. And then line 6.
Just highlight line 2 and then click.
You don't need to highlight it, just go into line 2, line 6, and then go line by line by line with Control and Enter. You will automatically be directed to the next line, and then it will populate exactly what's populated in my end. Yes, please.
Am I supposed to delete everything that's already in the console?
No, you can ignore what's in the console.
Oh.
So the core piece and everything that is important is the script, and to understand when to run which line in the script. That is really the key. So the script is basically orchestrating whatever happens in R, and R is just doing what the script tells it. Yes.
If you want to check to make sure you ran a certain line, how do you know in the console which one is line set?
That's $1 million question. That's a good question. So this is your logic. This is your logic in your code, because in the end of the day, you want to design your code in a way that you're running line by line by line by line.
I think I did, if I did 6, how would I do it when I went to the data and the table?
Yeah, so you know what each line does, and then you need to look at the environment. And so this is quite an advanced question, because down the road, this is also what a lot of analysts face as a day-to-day problem. Because if you're not sure you ran that line of code on line 300 and you're down at line 1500, you may not remember that. And that's actually one of those problems that you sometimes face. But yeah, it's a good question. Yes. Well, you arrange it like that in your script. So you arrange it in a certain fashion. And in the end of the day, what you really want to have, you want to have the code arranged in a way that you're basically just pressing Command and A, and you're selecting all your code. You press Control and Enter, and you have this run overnight. The next day in the morning you come, everything is ready.
How do you know if you wrote 260 and then
Yes, so I'm walking you line by line through, but in the end of the day, you want to have that code written in a way that you don't have to do anything. You don't have to manually go line by line. In the end of the day, you want to have that code to export whatever product you have. If you have a graph, it prints it somewhere as a PDF file. Which chart? Yeah, you wouldn't do that. If you're really programming and you really understand, so this is RStudio. If you program in R, or you program in Amazon Web Services, for example, which allows you to do it in R or in Python or whatsoever, you don't see the environment. So this is an RStudio specific facilitation of your work, so to say. It becomes a lot, I know. But this is what my vision for this class is. You get a little bit of a taste, right? It's like you're not walking out from this class knowing what programming is or how to program stuff. You get a first taste and you get a vision of what it entails, right? That's why I also make it super easy, give you the codes, and this is just, it's an exercise, it's a sandbox. And you do with it as you please. Yes.
we're never gonna have to write this by ourselves, right?
Excuse me?
We're not gonna have to know how to write this by ourselves, right?
Yes, you expected to write it. No, you're not. No, don't worry. No, it's yeah, that's the final exam. Then it's like 600 points. No, don't worry. You are not expected to become expert programmers in this class. This is meant as a sandbox for you to learn what data analytics entails. So it's playing in the sandbox with a little toy truck. It's a taste. It's a taste. The only reason why I made it. So I have a vision with this because some of you may be interested in computer science, some of you may be interested in data analytics, and it's just I want to take away the shyness from you guys that you have done it once and you see this is not Chinese and this is not really complicated. It can be super easy if you know how to run it, and that's why I want to expose you to that. Yes.
So I ran line 6 twice, I think. How do I undo it?
You don't need to undo it. That's the beauty of it. Because the only thing that line 6 did was it created a data frame here on the right upper corner. If you want to go back and you want to delete this data frame, you just go back to line 2 and you remove it from your environment. You wipe the environment empty. That is all it entails. So if you're gonna, okay, so these are the practical questions now. So let's go step by step, line by line, through what the code means to do. So if we go now on line 6 and we run line 6, we're building this data frame. You can look at the data frame graphically by clicking here on the table sign. You can also look at it by running lines 7, 8, and 9.
Run it again.
Well, you can. And that's again the beauty. Once you have loaded it, You can rerun it as often as you want. Nothing's going to happen. So you're just displaying it. You basically, with this line, you're telling R, show me the object. Show me what's in there. That's all it does. Equally, when you run line 10, you're basically asking, so we have now addressed the variable congruent and incongruent, which is a column in our Excel spreadsheet. We know how to address this now. So we're saying data frame M2, module 2, $sign incongruent and congruent shows me only that variable. If I want to know how long that thing is, so how many entries I do have for my variable, I say length, and length will give me the length of that. Why is that important? Because for some certain operations, you may need that, but that is too much information. So it tells you 24, which we also know from this graphical depiction here. It's 24 observations. It gives you the length of 24. You can also address this with dimension, DIM, the dimension of DFM2. Then it basically tells you 24 observations in 3 columns. So you have 3 columns and 24 observations. Good. So line 15 is now basically displaying, and you remember how we played around with like categorizing all the entries that were longer than 15 seconds as opposed to those that were shorter than 15 seconds. And you can do that in R by basically giving it a criterion. So we remember if we want to address a certain object, sub-object within the object, like a variable, we do DFM2 $sign congruent. If we want to restrict it, we need those brackets. And then we say DFM2 and give me only those from congruent where congruent is greater than 15. Consequently, R will go and only give you those that are greater than 15. And that's how we apply criteria. It's a simple code. It's not unlogical, and it's if you write it in that format, R will always do the same thing. And the beauty of this, think now how we did it in Excel with like pulling this down and propagating this all over the place. Now imagine you have a data frame with not 24 Stroop tests, but 24,000. If you need to have your criterion all the way down, you're going to spend a lot of time just scrolling, right? R does this in milliseconds. And that's where R becomes a very useful tool, how to operate large data sets. And yeah, so in my world, large data sets, not even 24,000 really characterizes it. So we're talking about 24 million. So that's a lot of data points and observations. So that you're scrolling the next 2 hours. Yes.
You have 1, then the next is 9, the next is 17. I have 1 and 12. You have a box and within the box is the 1, then the next line is 9 and 17.
Yeah. So this here is essentially nothing else, but it tells you. So this is observation 1, and it tells you this is observation 9. So it just gives you the entry in that line as it displays it. If I want to display this differently, I can just go a little bit. Yep. So if I'm pulling this to the side now, it will start to shift it. So this is just a question of your resolution. So if I'm zooming out, for example, it will change this now to 9 and 17. No, it doesn't actually. So it gives, it's nothing else but displaying the order in which your data is there. So this is not really data. This is just a visual display. It just gives you that starting entry. So this is spot number 9 in the data frame. This is spot number 17 in your data frame. So this, if this is different, that's just a reason of you zoomed in more or something is different in your R in your screen resolution. It's nothing concerning. Yeah. That depends which line you ran up there. If you run it for all, it should be the same numbers. Which numbers? The one on the very left or the overall numbers? All of the numbers are different. Yeah, so we can look at this after class. Yeah. Any other questions?
What is the whole purpose? Like, what are we supposed to get at the end? Just have code? Like, what is it?
We have the code, yes, exactly. So this is, and the output that you have here, this will be your deliverable of the practice lab. Can I do that? Yes, yes, yes. Good point. Yes, please. Yes. Sorry, forgot your name.
Sylvie, what was the
Sylvie.
last line that you ran?
The last line that I ran was line 22.
So if I accidentally ran line 16, is there a way to get rid of it?
Don't get rid of it. Just keep it. It's fine. Line 16 does nothing to the data. It's just displaying data. So all of these are basically only displaying data. So there's no harm done if you run one of these lines in a different order. Okay, so now we have line 17. Line 17 counts the entries that are greater than 15. Line 18 runs those incongruent. Here's a little change to make. Please change congruent and line 18 to incongruent line 18. That's why it was different. Okay. Okay, incongruent, yeah. So you need to replace on line 18 DFM to incongruent. That was congruent by mistake, twice congruent. In 18, it needs to look like that. So it's incongruent twice, not congruent. Yes.
When I run line 22, it just says error.
Line 22, yes, line 22 is a little bit ahead of the game. So we run line 17 and line 18. And then we have line 20. And line 20 defines a new variable. Line 20 packs the number 12 into threshold. And threshold is essentially now an object containing the number 12. You remember how we talked about soft coding and hard coding? We are now first officially soft coding things because we're saying now congruent, only display congruent data where congruent is greater than threshold, which we know is 12. So you're assigning a number to threshold, and then you compare actually your variable against that number as the threshold. So if we do that, we're getting only those that are larger than 12. Same with incongruent. And so this is for the reason that we have discussed. If you want to change now your threshold, you can do this within seconds by basically changing this to 18. And you run now 21, you only get those that are greater than 18. So you can run this, yeah, play around with it. Play around with it, and that's why I'm giving you this code, because I want you to kind of get your feet wet with it. So if you change threshold to whatever variable you're interested in, you can automatically have R redo that line of code and kind of give you exactly that result that you want to have, right? So if we do now, again, so line 22, incongruent needs to again be replaced with incongruent. Okay. So if you do now line 23 and 24, you have the same situation. Again, congruent, incongruent. Good. So that's basically, that's what we did for our Stroop data example. Then we have line 27, 28, and 29. Yes. Okay. What is the error? What does the error say?
Object threshold not found.
Yeah, you need to run line 20 first. You didn't run line 20. Okay, so if you go on line 20 and you press Control and Enter, then you can run line 21 to 24 again, and it should work. Good. So line, yes. Say that again. Sorry.
I have like, are the lines
Some of them have like a red dot.
Yeah, you clicked on it. That's this, right? Clicking on it again, then it goes away. So that's like a marker. You're marking a line because there's something special about this line. That's just for you to find it again. Yes. Okay, and change it to something else. Change it to 13, 14. No, just change the number 12 to 13. And then run line 21 to 24 again, and you're gonna get different results.
What do you change?
At line 20. You change 12 for 13 or 14 or 17.
Well, what's the purpose of changing?
While playing around with it, knowing how to employ it. Because so threshold is nothing else but an object that you can query, and the code line 21 to 24 will take threshold, takes whatever number is contained in threshold, and will use that as the new criterion. So it's kind of, it becomes a soft coded criterion. Yes, please.
The only thing I was supposed to edit on line 22 and 24 were changing the first congruent to incongruent.
Yes, the congruent. Yes, exactly. So it's line 22 and 24. The first congruent, please change to incongruent. You can just copy. Yes, then you run it again. Yep, no problem. Okay, good. So that was the Stroop example. We're now on line 27, and if you run it with the mean function, what you get is a mean. It calculates a mean of your data. It takes congruent and incongruent, calculates the mean, just like we discussed and did it in Excel. If you do mean minus mean, you basically get the difference between those two. And that will be something that we actually do quite actively moving forward, because that's basically comparing two samples, right? And this is what hypothesis testing basically entails. So we will do these subtractions of the means quite frequently. Good. So that was Stroop data. Now we're getting next, in the next 8 minutes, we're going to get to the volcano example. Lines 33 and 34 builds DFM3. And you guessed it, it's our volcano data. You know this already. We've done it in the volcano class, in the module where we discussed the volcanoes. Line 36 to 43 basically builds the frequency table that we did in Excel over the period of an entire hour, and was in milliseconds. So it runs this here as a so-called iterative loop. And it runs through the numbers from 1 to 17 and counts the respective frequency. Just run it. Just run 36 to 43. If I would be explaining an iterative loop anymore, you wouldn't like me anymore. So this is a little bit more complex, but it's a super important way to do iterative work. So if you are counting the ones, and then you're counting the twos, and then you're counting the threes, this is iterative work. So you're doing the same thing over and over and over with a different number, and you're telling R to do that for you. And you're telling it, do it from 1 to 17, count all the ones, count all the twos, up until 17, count all the 17s. That is an iterative loop. Yes, please.
In global environment, under data, it says value, and mine says I is threshold. Is that right?
Yep, that's yeah. I is this one, right? Yeah. So this being said, if you tell R to do this over and over and over, it basically will assign 1 to 17 to that I, and it will query this I then from here, right? So basically this I is being utilized to calculate this running counter.
Like this.
My frequency says NA.
Frequency says NA.
There's an error above.
You would need to run line 36, select line 36 to 43 and run this in once. Did you run 33 and 34? Run 33 to 43.
And then just highlight it and then click Control Enter.
Yes, if you run at the same time 33 to 43, it will automatically populate it.
I highlighted all of it and it traveled all the way down to here to like the 50s. And I don't know where I'm supposed to go now.
Okay, just if you do this with shift and just the cursor,
Yeah, but now it's all the way in the 60s, and I don't know. Like,
that's fine. That's
it
fine.
like travels all the way down. I don't know when it's just
So
happening.
yeah, so if you have this, you're just doing this. So this is how your code looks right now. No, no.
Like, I
No,
don't know
there's
what
something.
it's
Aha, that's a good one. Hold on. Good point. So if you press escape here, it breaks out from this pattern. You did an incomplete. You ran an incomplete line.
So like, what am I supposed to do about
You're
that?
also you're all the way down. You just go back up.
But is it still there? It's not.
No, you're
So
just
you never
starting it
use
from
one?
scratch. Just do 33 to 43.
And just,
Run this. We'll show you the frequency table. So now it's
okay, now what? Go to where do I go?
you deleted here something. Yet you deleted that. So Control and C restores that. Yes, running this now. That's your frequency table.
Okay.
All right, sure. Okay, so there are a couple of caveats in case you see here on the side a plus, and you say 1 plus. So you see here on the side, you see here plus. That is the reason, because you did an incomplete selection and you ran something which basically makes R think that you still want to add something. If you have that plus here, recognize it that you ran something incomplete. R is still waiting for something, press escape and gets you back out of there. Good. Yes. Yeah. Okay. Yeah. So I'm quickly in the last 4 minutes. I'm going to show you now what the deliverable of this class is. So you have DFM4. We need to rush, unfortunately. For those of you that are interested in learning R a bit more in detail, I happily, can we please have one conversation? Excuse me, ladies, one conversation. So if you want to learn more about R, I happily make myself available, and we can go on a Zoom session, on a breakout session at your convenience, or we find a time that works, and I go a little bit more in detail about things. So those of you that are interested, let me know. I happily do that with you guys. Good. I just quickly want to run through the deliverable. We have 3 minutes left. I want you to have this on recording, what is requested from you for practice lab 1. So last, you do DFM4. DFM4 will basically allow you to run that plot, and you're computing now this plot for the athletic performance that basically we have done in Excel. So this is the same plot we did in Excel. You remember it? That's the very same plot. So you do this plot that took us like 2 minutes to build. You're doing it in milliseconds an hour.
Do you want us to highlight the lines that you highlighted?
No, you don't need that. It's fine. So you can do this plot quite simply. And then lastly, we have Charity Navigator, and this is just DFM5, creates a new plot, creates a histogram now. And the histogram, it's on recording. I need to rush through it now. So basically shows an histogram of the scores, and gives you here summary statistics that gives you the summary statistics that are asked for in practice lab 1. So you can have your specific quantile numbers, you can have summaries, you can build various summary statistics very easily by just running line 66 to 70. And that allows you to complete everything that's needed for practice lab 1. So I'm doing now exactly what needs to be submitted, and I'm doing this on recording that you can go step by step. So can we please focus for a second? I just want to have this clearly on recording, what is requested from you for practice lab 1. Go click into your console, press Control and L, and this is true for Mac as well as Windows. Control and L. This will automatically clear the console entirely. It basically sets it clean. Now you click in the script, left upper quadrant, anywhere, and you press Command and A. For Windows computers, it's Control and A. Command and A is then followed by Control and Enter, where you say R, run this for me. So you're running every single line in your code, and you ran this all now in the console. Next thing you do, you go left lower quadrant in the console. You click at the very same entry that you see the cursor blinking here, and you're selecting this now, and you're selecting all the way to the beginning of that code until everything is selected. That's a little tedious, but unfortunately the only way to do that. Then you press Command and C like Caesar, or Control and C in Windows computers. You go on the spotlight, right upper quadrant in Mac, or you click on in a folder and you click and you make a right click in Windows and you say New Text Document. In Mac, you do Text Edit, and you build the Text Edit file. You open Text Edit. You get here a Text Edit file. You click on New Document, and then you press Command and V like Victor. And once you have all of this pasted into your text document, you're going to on File. So in Text Edit, you go on File, Save. You go somewhere in your folder, in your STAT folder, and you save this as STAT1021F, your family name, and your actual, what is it? Well, actually not, Practice Lab 1. So again, it's the course number and identifier, your family name, and Practice Lab 1. And then you save that and submit that. That's your Practice Lab 1. It's as simple. Okay, thank you very much. Those of you with technical problems, please come and see me and we will resolve this quick. Yeah, just a second.